All right, we're going to start on lesson 7E, which is solving radical equations. The main thing to remember when you're solving radical equations is that if you can, the first step is to isolate or get the radical by itself using whatever properties of equality you need to. And then once you have the radical by itself, your second step would be to get rid of that radical. And the best way to get rid of a radical is to um, undo it with the power. So since this is a square root, we're going to get rid of the square root by squaring each side. And if you square the left, then you need to square the right. That's a property of equality. Whatever you do to one side, you have to do the other side. So the square is going to take out the square root, leaving us with 2x minus 1. And 3 squared is going to give us 9. So then we're just going to solve this equation. You get 2x equals 10. Divide by 2. And you figure out that x is equal to 5. Now, one of the most important things you need to know about radical equations is there is the possibility of what we call an extraneous solution. And the reason you can get extraneous solutions is because you have squared something that wasn't originally squared. And by doing that, you're introducing the plus or the minus into the problem, or the option for that. So when I tell you to check your answer in step 4, this really isn't an option for you. This isn't, hey, let me just see if I'm doing it right, let me check my answer. You actually could do everything correct, come up with an answer to your equation, but when you plug it in, it doesn't work. So it's important that you go back, plug it in, and make sure you get what you're supposed to get. So when we plug it in, you get 2 times 5 is 10. 10 minus 1 is 9. And the square root of 9 is 3, which is what it's supposed to do. So we're going to keep it. So make sure you check your answer when you're doing these problems. All right, let's look at another example. This one, the radical is not by itself, so we actually have to go through this step here. We have 2 minus 1, which would give us a positive 1. We're going to subtract the 1 to the other side, trying to get the radical by itself. You get negative cubic root of x is equal to 2. Divide by the negative, you're going to get the cubic root of x equals negative 2. All right, so we've undone the radical by raising each side to the power of the index. Now this one is a cubic root, so what we're going to do for this one is instead of squaring both sides, we need to cube each side. The cube is going to take out the cubic root, and so in this case you're going to get x equals negative 8. Alright, so we get the negative 8, and we want to go back and test that. So 2 minus the cubic root of negative 8 minus 1. The cubic root of negative 8 is negative 2 minus 1. So you get 4 minus 1, which is 3, which is what we wanted it to be. So this one checks, and so you would keep that as an answer. All right, let's try it again. This one, we need to get that radical by itself. So we're going to move the 3x over by subtraction, and you're going to divide by negative 5. So you get the square root of x is equal to 2 minus 3x over negative 5. We want to get rid of the radical, so it's a square root, so we need to square each side. Now this is going to involve FOILing, so you're going to get x equals, and when you FOIL, when you have 2 minus 3x times 2 minus 3x, that's going to give you 4 minus 6x minus 6x plus 9x squared. Alright, So that's going to give you 4 minus 12x plus 9x squared. And then when you square the bottom, you're going to get positive 25. Okay, so this one's a little bit different because once you get rid of the radical, you then need to still solve for x. And so what we're going to do is get it set equal to 0. We need to get rid of that denominator, so I'm going to multiply by 25 and then bring it over, and you're going to get 4 minus 37x plus 9x squared. All right. So you want to see if you can factor this, or you want to see if you can you could do the quadratic formula also. So this one is actually factorable, and so we're going to change the negative 37x into negative 1x and negative 36x. We're going to factor by grouping, and in the first set there's not a GCF, so we're just going to have a 1 and a 4 minus x here. In the second group you're going to pull out 9, and that's going to leave you with a 9x, and that's going to leave you with a 4 minus x there. So if you're factoring this by grouping, you get 1 minus 9x and 4 minus x. So if you set each of these factors equal to 0, you're going to get 1 equals 9x, so 1/9 is equal to x, and you're going to get 4 minus x equals 0, so 4 is equal to x. So it's sometimes possible that you get two solutions, but before you absolutely commit to these solutions, you want to test them up into the original problem, which was that 3x minus 5 square root of x equals 2. So it was 3x minus 5 square root of x is equal to 2. If you plug 1/9 into that, you're going to get 1/3 minus 5/3, and that's going to give you negative 4/3, which is not 2. So this guy we can't keep. That would be an extraneous solution. So then you're going to try 4 in there. So we're going to go 3 times 4 minus 5 square root of 4, and we want to get 2. That's going to give you 12 minus 10, which gives you 2. So this one works, and you're going to keep it. But the 1/9 didn't work, so you had to get rid of that one. Okay, so that one's a little bit more involved just because once you get rid of the radical, you still had a pretty complicated equation to solve. All right, so here's one where we have two radicals in there, so it's not possible to get it by itself. You kind of skip over step 1 and go straight to step 2, where you're going to square each side. And a square root will undo a square, so you get 2x plus 5. Okay, and then you've got to FOIL this one out. And so you're going to get 4 times 2x plus 2 square root of 2x plus 2 square root of 2x and then plus 1. So you get 2x plus 5 equals 8x plus 4 square root of 2x plus 1. So that's going to give you a negative 6x, because you're going to subtract the 8x over, and then plus 4 is equal to 4 square root of 2x. So when you have more than one radical, there's actually two series here. you get rid of the radicals. You get rid of one at a time. So now we're trying to get the radical by itself. You get negative 3x plus 2 over 2 is equal to the square root of 2x. And now we want to get rid of that radical. So you're going to square each side. That's going to give you 9x squared minus 12x plus 4, because I'm foiling that out, equals 4 over 4 equals 2x, because the radical undoes the square. Bring that 4 up here. Bring that 4 up here. You get 9x squared minus 12x plus 4 is equal to 8x. That's a multiplication, not a minus. All right, set it equal to 0 because it's a quadratic equation. Subtract it over, you're going to get 20x plus 4 is equal to 0. Same kind of thing as before. You can choose to factor this out, or you can choose to do the quadratic formula. Last time I did the quadratic formula, last time I factored it, but I could have done the quadratic formula. Same thing here. This one's factorable. So I'm going to say minus 18x minus 2x plus 4. And I'm going to pull the GCF of 9x out, leaving me with x minus 2, minus 2, and x minus 2. So my factors are going to be 9x minus 2 and x minus 2, which gives me answers of 2/9 and 2. So those are my two answers, but I want to make sure that they work if you remember the original problem. That's what you want to plug your answers into. Okay, so if I were to plug 2/9 into this one, you have 2 times 2/9 plus 5, and I want to take the square root of that, is equal to 2 times 2/9, and then plus 1. So that's going to give you 4/9. You got to get a common denominator, so you're going to change that 5 to 45/9. And then you have 2 square root of 4/9 plus 1. So that's going to give you the square root of 49 over 9. And that's going to give you 2 times 2/3, because that's the square root plus 1. So 7/3 here. And then you get 4/3 plus 1 is 3/3. So that guy checks out. So we're going to keep our 2/9 as an answer. And then you want to do the same thing with our 2. So we're going to go 2 times 2 plus 5 is equal to 2 square root of 2 times 2 plus 1. So that's the square root of 9. So this is going to give you 3, and this is going to give you 5. So that guy's not going to work. So you're going to keep the 2/9, but you're not going to keep the 2. Now, I don't want you to think that you always ditch one of them. You might keep both of them, and that's okay too. All right, let's take a look at this one. You want to get the radical by itself, so we're going to take the 4 and move it over. That's going to give us our radical all by itself. You want to get rid of the square root by squaring. So you're going to get 3n plus 10 is equal to n squared plus 8n plus 16. It's quadratic, so we're going to set it equal to 0. You're going to subtract the 3n, subtract the 10. So here you get n plus 3 and n plus 2 are your factors. So n equals negative 3 and n equals negative 2. All right, so you want to test these. So if you were to do this, you're going to get 3 times negative 3 plus 10, and then subtract 4, and we want to see if you get negative 3. So that's going to give you 1 minus 4. So this is negative 3 equals negative 3. So this guy works. We're going to keep him. And then we're going to check this one. You're going to get the square root of 3 times negative 2 plus 10, all under the radical, and then minus 4, and that should give us negative 2. Negative 6 plus 10 gives you 4. So 2 minus 4 is negative 2, so this guy works also. So this is a case where you actually get to keep both answers because they both checked. Okay, so that's all the different situations that you might encounter when you're solving by radicals, and the most important thing, as you can tell, is making sure that you check your answers and that none of your answers become extraneous solutions.